Hello everyone, it's really good to see you here. So today we are going to solve a GFG problem and a very important graph traversal technique known as breadth first search or BFS. So what we have to do is we have to do breadth first traversal. So we have given a directed graph and we have to return a vector which is basically representing the BFS traversal of that particular graph starting from 0. So we have to keep this in mind. So now let's see its approach. So basically what breadth first search is, so let's suppose you have this graph like this. So what we do, you have some initial node or initial vertex as 0 and we have to start our VFS from this vertex. So what we do, we just go and check each and every connected component to this particular vertex. So let's suppose among 2, 3 and 1 is the smallest, that's why we consider 1 after 0, and then 2 and then 3, and after that we move ahead. And here, since these and these didn't have any connected components, so we cannot consider this. So here for 2 it has some connected component which is 4, so we add 4 at last. So how we are going to do this traversal is using a data structure which is Q. So Q data structure is used for DFS traversal of graph. So let's understand how we are going to do this, because yeah, so once we are at certain vertex, let's suppose 0, we are starting from 0. So what we do, we just add this particular vertex in our queue, and then we are also maintaining a visited array which is going to tell us about if that particular vertex is visited already or not. So initially each and every element is 0 inside our visited array, but once we are at 0 we just make it 1. So now once it's done, what we do in our queue, we just take this any temporary integer and just add this particular like queue front element inside that particular temporary integer, and then we append that particular temporary integer in our answer vector. So what it means is that, let's suppose we have the front as 0 in our queue. So what we do, we just store this 0 in some temporary integer temp which is going to have 0, and then what we are going to do is we are going to append that 0 in our answer vector. So initially let's suppose 0 is appended. Now what happens is that we run a loop to check each and every connected element for that particular 0 vertex or that particular temporary vertex, which is basically the front of our queue. Now here we can see that 1 is an element. So for doing that particular loop, we got 1, 2 and 3 inside our queue. Now again what we do, we just pop this one and check that after popping this one we are going to append here, and then what we check that if this one has any connected component or not. So in this case it didn't have any connected component, so we mark it as 1 and we just didn't go to check its connected component. And after that 2 is the top of the queue. So here for 2 you can see that 2 has a connected component 4. So what we do, we just pop out this 2, and then inside this it is going to be 1. So what we do, like since 2 has a connected component, so we just traverse uh, through the connected component of 2, which is 4, and we append it in our queue. So 4 is appended. Now again we have 3. So basically 3 got like popped out from the queue, and then 3 got appended here. So firstly 2 got appended and then 3 got appended. So since 3 didn't have any connected component now, so we go to 4, and again 4 is popped out and 4 is going to be here. And this is how we are actually going to like have our BFS traversal. And each time we visit some vertex for the very first time, we mark it as visited. So this is the overall approach, and now let's dive into its coding part. So here firstly a bool array which is of size v plus 1, and then we are initializing it with 0. Now what we do, we just firstly make a queue and queue which is of type int, and then we push 0th element because it is given that starting from 0 vertex, and then we mark the visited like index 0 as 1 because we had visited it. Now we run a while loop till the point the element inside our queue is not empty, like queue is not empty. Till that point we have to run this while loop. So temp is basically storing the front element of the queue, and we just popped out after storing the front element. So after that we just push our temp inside our answer vector, which is basically the top element of our queue, and then for each element or each temp we check how many connected components are there. So as many connected components are there, we have to push back that particular like element inside our queue. But before that we have to check if that particular element is already visited or not. So if it is already visited, then we cannot do this, or we cannot append that in our queue. But if it is visited for the very first time, then we mark it as visited first, and then we append that particular vertex in our queue. And the same way, after doing that, here answer is storing each and every time we are popping some element from our queue, and basically it is storing that particular element, and at the end we are going to get our answer. So let's try to submit this up. So yeah, this is the overall approach to solve the problem, BFS of the graph. And if you want to assess the code, then you can check the GitHub link given in the description. And this is it for this video. But before that, I guess for you, subscribing to this channel is not a very big deal. So do this, and thanks for watching.